Okay, so this is the next lesson in trig. It deals with what we call cofunctions. There are three pairs of cofunctions. We have sine together with cosine, tangent together with cotangent, and secant with cosecant. Now, the way that the calculator shows it, it'll say sin for sine and cos for cosine, tan for tan, and cot for cotan, and then sec for secant and csc for cosecant. So that's the way the calculator says it. Those are the abbreviations for it. Understand that when you see sin, you don't say sin, you say sine. Cos, you say cosine. Tan, you say tangent. Cot, you say cotangent. Sec, secant. Csc, cosecant. Now, in geometry, we predominantly use only sine with cosine. That's the most common. That's not to say that you shouldn't know the other pairs, but those are the most common. Okay, so this is a very important statement. A function of any acute angle is equal to the cofunction of its complement. So if you have sine, its cofunction would be cosine. And if this angle is 20 degrees, in order for these to be equal, this has to be 70 degrees. And that's because these cofunctions can only be set equal if the angles are complementary. Okay, so in order for two functions to be equal, they have to be cofunctions of each other and their angles have to be complementary. So I'll scroll to the next side. Let's investigate using ratio. So ratio is a fraction. So the sine of A, we are going to be pretending to stand here at A. Sine takes the opposite side and compares it to the hypotenuse. So the opposite side is little a, and the hypotenuse is little c. Now it discusses the cosine of B. So now we're standing at B. Why? Because it said so. Cosine's acronym is ca, and that's the adjacent. So the adjacent side here would be the A over the hypotenuse, which is also C. Now, if you notice, these are the same ratio. So what can we say? We can say that the sine of A is the same as the cosine of its complement, which is B. Notice C is not there. C is not an acute angle. C is a right angle, so you will never use it in these statements. Okay, the next one. Let's look at the relationship of the angles. Well, what do we know about angle A and angle B? Well, if angle A is 30 degrees, then we know angle B would have to be 60 degrees because they need to be complementary. If two angles are complementary, that means they add to 90 degrees. So if we have the sine of 30, for the sine of 30, well, 30 is the angle we're standing at. Sine is opposite over hypotenuse, so the opposite side is 1 over the hypotenuse, which is 2. Now we have 60, and it's cosine. Cosine is adjacent over hypotenuse, so the adjacent side here is 1 over the hypotenuse, which is also 2. So if you look at the angles, well, the angles have to be complementary as long as the cofunctions end up being equal. So therefore we can make a statement. We could say angle A plus angle B has to equal 90 degrees. Again, C is not a part of the problem because it is the right angle. We're discussing the acute angles here. All right, now here's some algebra. They're giving us a statement, and they're saying that the sine of A is equal to the cosine of B. So let's take a look at what we've been discussing. Well, sine and cosine are cofunctions. They're saying that they are equal as long as the angles are complementary. Well, what does that mean? That means angle A plus angle B needs to be equal to 90 degrees. Well, what does angle A have as its variable? Angle A is x. Angle B is 2x. And we know that if we add those two angles together, it has to equal 90. So now we have x plus 2x, which is 3x, equals 90, which means that x is equal to 30. Now this question actually doesn't even have any instructions, so let's just put here, find the measure of angle B. Well, angle B is 2x, so therefore the measure of angle B would be 2 times 30, which is 60. This one does not have a picture, but it does tell us that we're dealing with a triangle and we're also dealing with a right angle. So let's go ahead and draw that. We know angle C has to be 90 degrees, so we're going to put that there. A and B would be the other two angles. They are interchangeable at the moment. Now it says the sine of A is 5x and the cosine of B is 4x plus 8. Well, if A and B are the complementary angles, and if we have sine and its cofunction cosine, we know that cofunctions are equal as long as their angles are complementary. So, what is the sine of A? The sine of A is 5x. And what is the cosine of B? Cosine of B is 4x plus 8. Which means now we could find the value of x. We're going to minus 4x from both sides, which means we get x is equal to 8. And that is the answer because it said to find the value of x. So just try to remember, cofunctions are equal if their angles are complementary. Go to the next one. All right, let's practice here. Fill in the blank with a trigonometric function, a number, or an expression in terms of x. So we have an equal sign here. These are cofunctions. Cofunctions are equal as long as the angles are complementary. So if this angle is 20, this one would have to be 70 because together they have to add to 100. Oh, excuse me, they have to add to 90. Here we have cosine, and we don't have the trig function here, but we have 37 and 53, and 37 and 53 add to 90, which means they're complementary. So these would have to be cofunctions. So if I have cosine, the cofunction of cosine is sine. Okay, we have tangent together with its cofunction cotangent, and these are only equal if the angles are complementary. So if this angle is 42, this one would have to be 48 because together 42 and 48 add to 90. Well, now this is an expression in terms of x. If this is x, this would have to be its complement. So its complement is right down here, whole minus piece. Well, we know altogether it's got to add to 90, so that's your whole, minus the x, which is the piece. So cofunctions are equal when their angles are complementary. So another scenario, except instead of this just being an x, it's a 5x, but that doesn't change the process. We have cosine and sine, which are cofunctions. And if this is 5x, this would have to be its complement. And its complement is whole minus piece again. So it'll be 90 minus 5x. And that's your expression in terms of x. And last but not least, we have secant and cosecant. We have a number. So this would have to be its complement. So theoretically, we'd be doing 90 minus 13. But we know that 90 minus 13 is 77. Yeah. So the answer there is 77 degrees. Now, those are pretty straightforward. Let's take a look at these. X is a positive acute angle. Sine of x is equal to cosine of x plus 20. So here we have it again. Cofunctions are equal when their angles are complementary. What does that mean? That means that those two angles have to add to a 90 degrees. So the angle plus the other angle have to equal 90 degrees. X plus 20 has to equal 90. If we solve this, we get 3x plus 20 equals 90. 3x is equal to 70, which means x is equal to 70 over 3. We can leave it like that because it doesn't tell us where to round. Next one, we have the sine of x minus 3 and the cosine of 2x plus 6. Cofunctions are equal when their angles are complementary, which means they have to add to 90. So we have one of the angles plus the other angle has to equal 90. X minus 3 plus 2x plus 6 has to equal 90. 3x plus 3 equals 90. 3x equals 87. X is equal to 3 goes into 8 2 times with 2 left over, 29. It says find the value of x. The value of x is 29. All right, we're almost there. We have a scalene triangle, and the measurement of angle C is 90, which equation is always true. So it looks like here we're using trig functions, not numbers. So the sine of A would be here. Cross from A is CB. So this would be CB over the hypotenuse, which is AB, is equal to the sine of B. So here's B. The opposite of B is AC over the hypotenuse, which is AB. So that we know is not correct. Now, we also could cross out choice 3 because we have a C here and we're never standing at the right angle, so we know it can't be choice 3. Now, let's go back to A. So we're standing at A. Cosine is adjacent, which would be AC over hypotenuse, which is AB. And we want to see, is that equal to the cosine of B? So B would be here. Cosine of B would be adjacent, which is BC, over hypotenuse, which is AB, which is also not true. So hopefully it's choice 4. So sine of A, we're standing at A, is opposite over hypotenuse. And now we have cosine of B, which is adjacent. Adjacent to B would be BC over hypotenuse. And that is a true statement, which means choice 4 is the answer. All right, it looks like we have one more. If angle C is a right angle, so let's draw it, in right triangle ABC, and they tell you the sine of A is 0.3x plus 4, and cosine of B is 0.2x plus 6, find the value of x. Well, the sine of A is equal to the cosine of B. So cofunctions are equal if their angles are complementary, and A and B add to 90. Now what is the sine of A? The sine of A is 0.3x plus 4, and the cosine of B is 0.2x plus 6. We set these two things equal to each other because they are not the angles, and then we solve for x. So 0.3 minus 0.2 is 0.10, or just 0.1x. Which means 0.1x is equal to 6 minus 4, which is 2. Which means x is going to be equal to 2 divided by 0.1. And 2 divided by 0.1 is going to give us 20. Find the value of x. We are done. All right, that is the lesson. Hopefully you will remember that there's two things you need to do here. One, cofunctions are equal when their angles are complementary. And that means either you're setting things equal to each other, or if they're the angles add to 90 degrees.